Hey everybody, thanks for stopping by. My name is Cliff Totten and this video is about the brand new DJI Mavic-2 Pro and the Zoom versus the DJI Mavic Air and the Phantom 4 Pro Plus 2. So what I'm doing in this video is really just one thing. It's a resolution, sort of a deep dive analysis of these cameras. Now, there's a lot of things that go into buying a drone and what drone you want to get and what it has, a lot of features. I'm not going to cover anything about the OcuSync or the foldability, the portability. I'm not going to talk about how the drone flies or any of the features about the drones, any of them. And I'm not even going to talk about dynamic range right now in this video, noise performance, or anything like that. I'm just going to discuss one simple topic, and that is resolution and resolution alone. Now, I probably will do another video shortly here that does discuss dynamic range, the color gradability of 10-bit in the Mavic-2 Pro, and some noise performance and that kind of stuff. So I'll be doing a different video for that, but this video is all about resolution and just resolution only. So honestly, 50% of you probably don't even give a damn about resolution. You might say, well, it's 4K versus 1080. I can't even tell the difference. 1080 looks fine to me. In fact, probably most of you aren't even going to watch your drone footage on a 4K monitor. You're probably going to watch it on your iPad. You're probably going to watch it, on a 1080 television. So why do you care about resolution? If you really don't, this video is not for you, because there's going to be a lot of pixel peeping and sort of a semi-lab work that I'm going to be doing in this video that's probably going to bore the crap out of you. So this video is intended just for people who care about resolution and clarity and stuff like that. A lot of people have been demanding that DJI give them a 1-inch sensor in a folding drone. DJI did that. Now, a lot of people don't even care why they want a 1-inch sensor. They just know they're supposed to want a 1-inch sensor, okay? So DJI gave it to them, and for a lot of people, that's all they care about. They don't care about the reasons why a 1-inch sensor is better than a smaller sensor. They just want a 1-inch sensor. That's all they know, and that's all they care about. Well, you got it, all right? So anyway, if you're that category of people, this video is not for you. It's going to bore the hell out of you, and you just go ahead and turn it off right now. Okay, so what I'm going to do is something you're not supposed to do in a YouTube video, which is go straight to the conclusions right up front. Okay, I'm going to tell you what I found out about these drones, and so there's some pretty shocking stuff in here, and tell you right now what they are. So if you're interested in what I found, you can go ahead and watch further. If you look at the stuff and say, you know what, I don't care, you can go ahead and turn the video off right now. I know your time is really important, so I don't want to waste anybody's time. So this is just for the people who really care about this stuff. My conclusions are this. All DJI drones look pretty good. They all have a for what they're designed for and for the price range that they sit at, they all have a decent look to them. They all look decent, okay? Good dynamic range, good noise performance, at least good, and decent and good resolution, okay? One of the things I learned is that the Phantom 4 Pro smokes all of the others in the area of resolution and detail. Even though it has the same image sensor, it kills all of the other drones, especially in wide view. The rest of the drones, the Mavic Air, the Mavic-2 Pro, the Mavic-2 Zoom, are basically roughly about the same in resolution in their wide mode, their normal wide mode. They're all about the same. There isn't much variation between those drones in wide view. Now, when you go to the HQ view of the Phantom or the Mavic, I can't get these names right, Mavic-2 Pro, then you do get a little bit of a resolution bump in that mode, but not a lot. But again, the Phantom 4 still crushes all of them in clarity and detail. Next one is a kind of a big one, and the Mavic-2 does not truly use the full 1-inch sensor that DJI has installed in it, okay? It's only using a fraction of that in both modes, whether it's in FOV mode, which is the full wide mode, or it's HQ mode. Neither one of those modes uses or scans every pixel on that sensor. It's not using the full 1-inch sensor, and I'm going to show you why that's the case. It's actually line skipping, pixel binning, or doing a crop out right in the center of the sensor. So it's not using the whole sensor that we've been asking for. Another pretty crazy one is that when you compare the Mavic-2 Pro's 2.7K versus its 4K in wide full FOV mode, you're going to see that the resolution on both of those is very, very close, almost the same. Again, we're talking a 4K, quote unquote, versus a 2.7K, and they are almost identical. That really kind of pissed me off when I first noticed that, and when I first saw that. I've kind of gotten over it since then, but that didn't sit well with me when I first noticed that. So why, DJI? Why are you doing this with the Mavic Pro 2? The Phantom 4 Pro, okay, I have the version 2, scans every single pixel, does a full pixel readout, okay? It's a 20 megapixel sensor, but full pixel readout is a 14 megapixel in a 16:9 4K 16:9 crop. That's 14 megapixels in that image. The Phantom 4 Pro scans all of that and scales it down to 4K, which is 8.3 megapixels, okay? The Mavic2 Pro Mavic-2 Pro does not do that. It actually line skips, okay, or pixel bins. Now, what is line skipping and pixel binning? Pixel binning is when you take clusters, RGB clusters. Yes, there's 2 green for every red and for one red and one blue photo site, okay? You cluster these photo sites and you average them mathematically, each cluster, and the cluster can be a different size, whatever size DJI wants it to be. They average it into one value, and it is a crude way of downsampling 14 megapixels to an 8.2 or 8.3 4K image without having to do a full pixel readout and scale all those pixels in real time. Okay, it's a very crude way of doing it. We know their image processor that is in the Mavic-2 Pro can do what the Phantom 4 Pro is doing, but for some reason, DJI is not doing that. Secondly, line skipping is when you read out, if you think of the pixel, the sensor as being a grid, okay, a grid of lines, horizontal and vertical. What they do is they scan every other line. So they'll read line 1, skip line 2, go straight to line 3, read that one, skip 4, go to 5, and you get the idea all the way down. So what you get is an image sensor that has all of the odd lines scanned and an image made from that, and the even lines are left out. They're unscanned, they're untouched, they're unused. So if you scan every other line on an image sensor, you're only using half of its surface area. Think about that. Half of its surface area. If you had a 1 million piece jigsaw puzzle of, I don't know, let's say planet Earth, okay? And you took 500,000 of those jigsaw puzzle pieces out, threw them in the trash can. With the others you had left on the table, you combine them together, okay? What's your image of planet Earth going to look like? Well, it's going to have detail problems because you've just thrown out half the jigsaw pieces. So you compress them all into a new image, and it's scaled down, and you have less pixels in it, but the image is distorted. So anyway, that's how you do a very crude kind of a scaling, and that is what the Mavic2 Pro is doing. And I honestly, I'm going to theorize at the end why I think this is happening. And honestly, it is very possible that it's a marketing decision to protect the Phantom 4 Pro, and maybe even more importantly, the future Phantom 5. Both of those drones do a full pixel readout, so maybe they wanted to create a barrier between the two of those and have a softer image on one and have the full pixel readout on the other two drones. So it could have been a marketing decision. Or it could have been a sensor heat problem, a sensor overheat problem that forced them to go into a line skipping mode, or of course the HQ mode, which is nothing more than a center crop. Okay, sensors get hot. When you read them fast and when you read them more, they get hotter, okay? So to cool the sensors down, you can line skip and you can crop out, do center crops, and that will reduce heat in the sensor. We're gonna talk about that more towards the end, the conspiracy theory kind of part of this. So it might have been because they didn't want to, but because they had to do it. That's an interesting idea. Anyway, so let's go ahead and get into it right now. Again, this is all some pretty nerdy stuff. If you've stayed this long and are willing to go and take a look at this stuff, I imagine that you're interested in what we're going to be showing you. Again, this is just resolution. You're going to hear me say that word resolution and detail and clarity a lot in this video. Okay, that's all we're discussing in this video. That's all we're analyzing. So here we go. So in this first test, what I've done is basically just did up an indoor little scene setup with some lighting in it, so it's bright enough to where I could stay at 100 ISO 0 dB for all of these cameras. So any noise that you see is the native noise at 100 ISO/0 dB that these cameras produce. And again, I'll do a video more about noise because I think there's a lot to be said about noise performance of these sensors later on. Anyway, so this is not a dark room. It's a fairly bright room, and they're all at baseline 100 ISO. If you see the two playing cards on the top left and top right corner on the wall, that's what I use as my 16:9 marker to adjust the field of view for each of these cameras so that they wound up having the exact same field of view. As you know, the Phantom is 24 millimeter, the Mavic-2 Pro is 28 millimeter in wide FOV, and the Air is 24 millimeter, and the Zoom is 24 millimeter. So I also did tests with the Zoom at 28, just so that it matched the Mavic-2 Pro. So anyway, so this is the poster and the card and all that stuff is kind of interesting to see, but really it's the resolution charts that I'm going to zoom straight in on and take a look at, because that really tells the story right there. Resolution charts, they are designed to break all cameras. All cameras break. The point that we care about is at what point do they break? Do they break early? Do they break later on down the chart? And that's going to tell us, give us an idea of how the resolution is. And by the way, this was just a resolution chart that was printed out and taped to a wall. Those 2,000 line, 1,500 line markers, all those markers are not real lines to be measured in a number like that. So you'd have to get a real size, print out and, get your camera spaced out in front of that with its size just right. I couldn't do that with this drone, so with these drones, so I just tossed it on the wall, and it's a small printout, and just stuck it. This is only for comparing all the drones together. So don't go by the numbers. The numbers don't mean anything, but do go by the actual circles and the fine resolution, patterns that are on the chart when you compare them all together. Hope that makes sense. That's kind of complicated, but anyway, throw it in. Let's go. Okay, so this is the Mavic Air, and let's go ahead and zoom in on that chart and take a real close look there. And you can see that circles 10, 11, 12, 13, 14, 15, 16, 17 all have full resolution inside of them. 18 seems to be the breaking point, and of course beyond 18 is pretty much destroyed. But look, this is a pretty good performance. We've got right until 17. This is a good performance for the Mavic Air. Okay, the Mavic Zoom at full wide. Again, really good performance right up until about the same, 18. Very, very good for this little image sensor. Okay, it's the 2 Pro HQ sensor crop. Again, about the same performance, looks really good. Between 17 and 18, we'll call it 17, but again, this is very, very close to the Mavic Air and the Mavic Zoom in full wide. Not bad. And here is the Phantom 4 Pro, and wow, what a difference. The resolution on this is down to about 20 to 21 or so, right around there. You know, it's not about just having a 1-inch sensor. It's about also how you read all those pixels and how you process those pixels into an image. I also have to wonder if DJI is not using an optical low-pass filter on this sensor. But anyway, this is pretty damn good. So this is the Mavic Pro 2 in FOV wide mode. Again, this is exact same image sensor. But look at how the frequencies just sort of mash into each other, and there's a lot of soft aliasing going on. We can only get down to about 15 barely onto this this chart. But this is just a good example of how, you know, reading a sensor out changes the quality of your image. It's not just a sensor, it's how you read it. Okay, so now you're looking at this chart going, whoa, why does it look so different? What's going on with that, with that shape? Why is it so soft like that? And why does it have those swirly sort of a shape inside those concentric circles like that? And although it's impossible to say this definitively, okay, but commonly what you see what happens when you see stuff like that in the chart, especially that softness like that, you have to think pixel binning, okay? And that's where I said earlier about clustering pixels into single values as a crude way of image scaling, okay? Again, we're going from 14 megapixels down to 8.2, 8.3, whatever it is, in 4K, or line skipping. And again, line skipping is just that. You read every other line and you combine your image from that. And of course, the artifacts of line skipping are what looks like in that chart there. It's soft, swirly moire patterns and aliasing and general softness. So I think just from looking at these charts, I really have to believe that there is a line skipping or pixel binning issue going on in the Mavic-2 Pro. So I thought this was huge. When I saw this, I almost fell out of my chair. And again, this only exists in FOV mode. In HQ mode, it's much better. So definitely DJI knew what they were doing when they named these two modes, FOV and HQ, because one is high quality and the other is FOV. So they knew what they were doing here. They saw this evidently. So we're going to talk more about why I think they're doing this. And I think the reasons are kind of important toward the end of this video. So let's keep on going here. So this is just a side-by-side quad view of these three drones, and you can see where they resolve to and where they break at, and kind of compare. It's pretty easy to see when you see them all together like that. Okay, so right now you're thinking, God, you know, Cliff really hates the Mavic Pro 2, and that's far from the case. I love that drone. I'm going to keep that drone. It's just that I was originally wanting to buy the Mavic-2 Pro to replace my Phantom 4 because I thought it would be a great replacement. But after seeing these results, there's no way that I could replace the Phantom 4 Pro with that, with the Mavic-2 Pro. There's no way. But I will keep the Mavic-2 Pro because it's a great drone for a lot of things. It just is not the beast that the Phantom 4 Pro is. So I just want to put these both side by side and really point out that they are both using the same sensor and should be scanning the same number of pixels in the same way, but they are clearly not at all scanning that sensor the same way. So in the outdoor scene, I did a very similar thing. I set up a scene, I used a lamppost, and I used a bamboo stick to make my 16:9 width of the shot, so I was able to move each drone forward and each drone back on their wide and tele settings, so that I could always line up the sticks on both sides so that we got a similar field of view. You'll see that the background, because of the depth, is going to be different on both of them. But for the most part, they are pointed at the same thing, and they have the same field of view. The center point for this test is really a pot. It's sort of a grass pot in the middle there near the shed. Interestingly enough, that pot is a living piece of the 40-yard line of the Miami Super Bowl, I think it was 44, with the Colts and the Saints. So I actually was able to get a piece of that 40-yard line, took it home with me, planted it, and it grew. So that's a living piece of the 40-yard line. Thought that'd be pretty cool. If you're a Saints fan, that is hallowed ground. But anyway, it's a living piece of the Super Bowl in my backyard. Anyway, so anyway, that was my center point for focusing on all of these shots. So let's go ahead and take a look. So these are just individual full screen display of each of the drones. The Mavic Air looks very good. I can't complain about that, especially for its image size. The Mavic Zoom also with a similar sensor definitely looks very close to that. Might have a little bit cleaner noise performance. And the FOV wide on the Pro definitely looks softer. Not much, but definitely a little bit softer. And the HQ does look a little bit sharper, so they definitely named them properly. And we switch over to the Phantom 4, and everything just stands out. Much more detail. This is not just sharpness, this is actual detail. And zooming in here to our Super Bowl 44 pot there, and doing some more comparisons, and that FOV wide is just getting spanked by the Phantom 4 Pro V2. In order to get really anything clear and sharp and detailed out of the Mavic Pro, you have to use that high quality mode that they gave us. Really FOV mode just doesn't even look as sharp as the other cameras in their wide mode. I thought this was pretty striking. So in HQ sensor crop mode, the Mavic-2 does get closer to the Phantom 4 Pro in resolution, but still the Phantom 4 Pro is the clear winner. And it's very important to know that the Phantom 4 Pro is using the entire 1-inch sensor, while the Mavic Pro 2 is only using a smaller portion of that sensor. They're not even giving you a full 1-inch sensor in the best mode that it's got. Meanwhile, the Phantom 4 is. You're getting a full 1-inch sensor. So here are the three Mavics stacked together in their widest mode. I prefer 24mm over 28 any day. But you can see they're all very similar. There isn't a huge difference. You can definitely see that the Mavic Pro's 1-inch sensor is cleaner, even though it's not scanning all of the photo sites. Those photo sites are still larger, and they do have a better signal-to-noise ratio, so you are getting better noise performance on that Mavic-2 Pro's 1-inch sensor. Okay, I just want to take a second to talk about softening your image in camera. When you use a -1 or -2 sharpness setting in your picture profile, that is a destructive process. You're taking out detail from the image and you're saving it that way. No matter what you do in post, you can never regain that detail. You can try to sharpen it in post, back up again, all you want, but remember, sharpness and detail are two totally different things, completely different things. When you take out detail from an image and save it that way, all the sharpness in the world will never put that detail back in there. So the idea is run your cameras at least a 0, but preferably a +1. What that will do is it will capture more detail, and on umbrella processors, which these Mavics and DJI drones use, when you add a +1, it actually lowers the noise reduction processing, and it lowers the side effects and the artifacts that noise reduction causes. That waxy, sort of blobby, kind of a watercolor look is reduced. They actually dial back on that noise reduction when you add a +1 in sharpness. You get more detail. Yes, you do get a little bit more noise, but this is something you can deal with in post. It's much better to soften your image in post when you get home and back in your video editor. That way you can soften it the way you really want it to be soft. You can surgically do it, okay? It's the easiest thing in the world in almost any video editor that you have. Softening your image is the easiest thing you could possibly do. So do it in post. Don't do it in camera. In camera is a destructive process. You'll never get it back. In post, you can always play with it. You have the option to do whatever you want to do and take some out, put some back in. You have a chance to, you want to archive it with all the detail that you can possibly get. So that's why all of these settings here used a +1 sharpness on all of the camera settings. So in my opinion, don't do a destructive thing by softening your image in camera. You'll never get it back in post no matter what you do. And here is the very last sample that I've got. This is the 4K FOV full wide mode versus the Mavic Pro 2's very own 2.7K mode. Now, if I didn't put the indicators there at the bottom, you probably wouldn't be able to tell much of a difference. There is a slight difference. It's not huge, but you got to understand something. One of them is quote-unquote 4K, line skipping, and the other is 2.7K. So it's 2.7K versus quote-unquote 4K, and there just isn't a huge difference. Okay, this is like a real controversial part of the video, and I'm going to talk about why I think DJI did this. They did line skipping and or pixel binning, but I think it's line skipping, okay? When the Mavic-2 Pro uses at least an Ambarella H1 processor, at least, if not an H2 processor. We know that the Phantom 4 uses an Ambarella H1. So we know that their processor is powerful enough to do a full pixel readout, okay, and a full pixel scaling. It can do it. DJI chose not to. Now, it was either because of marketing reasons, because they wanted to keep a wall between those the Phantom line, the Phantom 5, the Phantom 4, and the Mavic line, and just wanted to keep a definition there, that marketing difference. I mean, think about it. If you had full pixel readout on a Mavic-2 Pro, why in the hell would you need to buy a Phantom 4 or even a Phantom 5 for that matter? So this is very important from a marketing standpoint, that there is a barrier between the two models. I mean, they're going to be asking a lot of money for that Phantom 5, and it's going to have an image that is significantly better than the Phantom 4. The other possible reason that I could think of, and if anybody can think of anything else, let me know, but the answer is heat. Okay? Now imagine this. Now, I hope this doesn't piss people off, but I have to say it out loud. Okay? I might be wrong, but I got to say it out loud. I have a feeling I think I might be right about this, but you have an event, the See the Bigger Picture event, and you have this whole thing ready to go, and you have your engineers come to you 2 weeks before the event and say, "Sir, we got a problem. We're burning up our 1-inch sensors on the Mavic-2 Pro. They're overheating. They're burning up. Holy crap, what do we do?" Okay, now this is them using a full pixel readout. DJI postpones the event, calls up Ambarella, and says, "Guys, how do we cool these sensors down?" Now think about those two cameras. The Mavic-2 Pro has a 1-inch sensor in a tiny cube, a little tiny cube, and that thing is packed in there with very little space or metal to wick the heat away. Now, what do we know about sensors? The faster you scan them and the more you scan them, the hotter they get. Look at Sony, the people that manufacture that sensor. Even they have a very hard time dealing with heat in their image sensors, okay? And that little sensor is it is really packed in a tiny little box, okay? If you look at compare the Phantom 4 Pro camera in size versus the little tiny Mavic 2 Pro, if you just look at the back of both cameras, you'll be able to see that the back of the Phantom 4 Pro, it's probably about 3 or 4 times the surface area. 3 or 4 times the surface area, if not, and that's just the back. Around the sides, it's a thicker. The whole thing can wick away heat much better than that little tiny little box that the Mavic-2 Pro has. So your engineers go to you and say, sir, we're burning up. This is bad. We don't have time to redesign our gimbal, to rebalance and use a larger camera. We don't have time to put a cooling fan. We don't have time to do anything. We're sort of backed into a corner. What do? You postpone the event, you call up Ambarella, and you say, guys, help us cool these sensors down. Ambarella says, look, there's 2 ways that you can cool an image sensor. Number 1 is slow the clock speed down. The clock speed is the time that it takes to read the first line all the way to the bottom line. It could be 20 milliseconds, it could be 30, 40 milliseconds. And that scan speed, the speed at which they scan those lines, the faster they clock it, the hotter it gets, okay? Faster is better though, because what happens is it helps you avoid rolling shutter. Rolling shutter is what makes straight lines turn into wobble, jello effect, okay? So if you slow that clock speed down, you're gonna get more jello. It's gonna be more like this. That's bad. Yes, it will cool your sensor. Sony does that on a lot of its cameras. They use a slow clock speed to keep the sensor cooler, keep it from overheating, okay? But if you do it, if DJI does it on a drone like this, people will freak out because it's going to cause, especially when you pan left and right, and it's just going to wobble like crazy, okay, the slower you clock it. That's the first way to cool an image sensor. The second way to cool an image sensor is to scan less photo sites, okay? If you scan less photo sites, whether it's by line skipping, or doing a center crop where you're just using the middle of the sensor, if you line skip, you're only using half the surface area. If you only center crop, you're using only a small fraction, or a certain fraction anyway, of that image sensor's surface area. Both of those ways, it looks like DJI chose. They chose the clock speed's fast, so it does scan quick. So there's not really any rolling shutter problem, so they didn't pick that option. But it seems like they picked the other 2 options, okay, to control heat. So did they give their engineers 1 month to go back to Ambarella and have them reprogram a line skipping and FOV mode, okay? Get that figured out in the software, because it only would have been a software change. You don't have to do anything hardware to change that mode, the full readout mode. And then reschedule the event after they saw that it was working fine and their image sensors were running at a good temperature. I don't know, but it certainly looks to me that this could be the only. Why else would DJI do this if it wasn't for the marketing side? If they really wanted to do full pixel readout, because their image processor can do it, we know that, but they chose to go the other direction, it was either marketing or it was a heat problem. Heat. So I don't know the answer. Only DJI knows. There's probably only a handful of people at DJI who actually know the real answer. I hope it was a marketing decision and not a heat one, but it might have been. So anyway, I don't want people to think that I'm trashing the Mavic-2 Pro. I'm really not doing that, okay? I love that aircraft. The camera is good, it's solid, it has a good noise performance, okay? The signal to noise ratio is good, the dynamic range is good, all right? So it has a lot of great features. It just doesn't have the resolving power that the Phantom 4 Pro has. And I got a feeling that they're never gonna allow it to have that, either because of heat or marketing reasons, one or the other. So, anyway, I hope you got something out of this video. I'm sure it's gonna probably make a lot of people angry. And, you know, why are you doing this? Why are you putting drones on charts? And why are you looking so closely? Why are you paying so much attention to the images of this thing? Just go fly and don't worry about it. Yeah, for people like that, I get it. You know, there's probably, there's more people like that than people like me who are really into the imagery, you know, part of it. People just want a 1-inch sensor. They got it. A lot of people don't care why a 1-inch sensor is good. They don't even know. All I know is they're supposed to want it, and they scream for it, and they got it, and that's all that's it. That's where it ends. They don't care about anything beyond that. So anyway, put your comments down below. There's a lot of material for people to really go apeshit over. So just go ahead and put all the comments down and fire up those flamethrowers, and you know, hope you got something out of it. So I don't think there's probably any video on YouTube that does such a deep dive as what I did. Maybe there will be, maybe there is. I just haven't seen it yet. I've been looking around, haven't found any yet, but this gets pretty granular. So anyway, have a good one, and thanks for listening to my ranting. And if you like what you see, subscribe, and love to hear a lot of great comments down below, either thumbs up or thumbs down, love it or hate it, whatever it is. I can't wait to read it. All right, thanks guys.